Say hi, I'm Richard McDougall in the CTO office at VMware, and I'm here at VMworld and managed to grab a couple of interesting people to talk about big data. So Zubin's here from Mu Sigma, and he's the head of innovation at Mu Sigma, and they're a consulting company that does a lot of application development. I really wanted to sort of dig into the details of like what do the application architectures look like.
Sure.
So maybe you can tell us a little bit about what you do and we dig into some questions.
Sure. So I head up innovation at Mu Sigma. It's a large professional services company. We call us the largest pure play analytics provider in the world. And what I mostly do is with the innovation area is to keep track of all the newest technologies and the newest statistical techniques, and then drive that through our ecosystem. So big data is one of those new technologies that we're definitely in the last 2 years been very interested in from the analytics perspective.
Yep, that's been a really interesting space for VMware, recognizing that it's a big space for us to grow into and applying our technologies in the space as well. So what are some of the interesting use cases that you see that?
So one thing we think when we think of big data, a lot of people think it's about the data. It is about the data, but to me, it's more of a metaphor of a lot of disruption in the industry. So I've been in this business about 18 years, decision sciences. The last 18 months, I've never seen anything like it in my life. I mean, the excitement, it's kind of it feels like a renaissance is going on in the industry with respect to this computational infrastructure that Hadoop and big data technologies are providing. So to me, it's more of a metaphor for disruption. And what we're seeing because of that, we're seeing a lot of people rethinking about their data infrastructure. What should the future look like? How can we handle petabytes of data that we'll soon be having? And how does the analytics fit in, and what technologies should we be thinking about today?
So one of the interesting things is I often hear analytics equals Hadoop, and so if you've had a lot of experience building real applications, so what are the components you would see as just pull together applications?
Good question. So usually what it starts is that the client will say, we have a big data application, we want to, what do we do? We have these use cases. So it usually starts with the data tier, right? Where you see a relational world and you see the Hadoop world. You do see them coexisting. So we do see, writing SQL to the relational tables, but a lot of that sometimes is actually processing that information into the Hadoop HDFS layer. So we ETL that information into the HDFS. The reason why we do that is we want to run our analytics algorithms onto the Hadoop platform. But it's not always Hadoop. I think it depends on the definition of Hadoop. A lot of people think Hadoop is MapReduce and HDFS, but I think from hearing some of the talk today, Hadoop is more than MapReduce. It looks like the new 2.0 version of Hadoop is more about a parallel model where you can pick and choose different parallel models you like for your use case. But on top of that, we have a middle tier. And the middle tier is usually, for the analytics perspective, is we're seeing a lot of traction with Java and R, especially R. R is being utilized on the cluster itself.
So you're saying that people don't necessarily write MapReduce in raw MapReduce. So how common is it for people to actually write raw MapReduce
Java? That's a good question. So a lot of people, they'll decompose their analytics work into two areas. One is all the ETL that has to be done. And the ETL, they'll pick either Pig or Hive, depends on what their preference is. But we're seeing Hive is used more and more just because people know SQL already. So they'll do their processing, get the model-ready data from that ETL perspective. Then they'll switch over to, let's say R. And then there's two choices there. One is there's some packages, like RMR is one, where you can have, you have to write MapReduce in this case. The good thing about Hive, you just write SQL and it compiles it in MapReduce for you. But on the R side, you do have to, in the Java side for analytics, you do have to write some MapReduce jobs today. There actually isn't a lot of libraries that are available in parallel form for the techniques we use.
So if I just take a standard R program and just run it on RMR, does it run in parallel across the cluster?
Great question. See, I think that's the, no pun intended, the big elephant in the room. For what we call embarrassingly parallel problems, like for statistics, counts, max, mins, averages, medians, easy to do, right? Parallelizable very easily. If you want to run a generalized linear model like a regression, logistic regression, Poisson regression on a huge data set, that's not so easy to do. You can't just take a package from R and run it. It doesn't work. You have to parallelize the algorithm so it runs in that environment.
So it sounds like there's a layering that's going on here. We've got all the data being ingested into HDFS. Then we've got some MapReduce, but mostly people are writing in Hive on top of that. And then we've got an additional layer on top of that, which is an advanced analytics layer or something. That's where R fits, is it?
R or in Java we're seeing, and those are the two major tools. Weka libraries they try to leverage, but there are writing a lot of map-reduced jobs in Java, but the cool thing about R is that a lot of people are treating like a controller, like a glue code.
Yeah.
Well, they'll submit an R Hive job through R, they'll submit an RMR job through a map-reduced job through R, and they can process that data into a data frame and do some local information on it.
What about Python? I heard SciPy.
Python too. Okay. That's a good one. Actually, Python's actually quite popular as well.
So,
I missed that one, sorry.
So what happens then as far as, so we've got this platform which almost looks PaaS-like to run the map-reduce tasks, but now I've got to run some Python, I've got to run some R, I've got to run some R connected to it. So is there something missing here? Is there some framework components
Yeah, I think so. There's some orchestration layer, right, to kind of link all these things together and kind of automate the workflow in essence, you know. So once you have these jobs done, you have to automate them usually, and they have to score something or produce some output, usually if it's successful, in a continuous fashion, right? So a couple things. So if you have data at rest, we call it, like your classic batch data versus data in flight. The data at rest, what we're seeing as a best practice is people are using BPM tools, actually using a business process modeling tool, adding custom components like a HDFS component, a MapReduce component, an R component, and making that part of a process flow on the batch side. That's interesting. On the real-time side, I think that's evolving. So there's message queues, we're seeing Camel routing, we're seeing TIBCO products being used a lot there, and we're also seeing some of these newer technologies like Spark and Storm from Twitter that may have some merit there. But I think that's not as evolved as more of the batch side.
Right, that makes sense. Great. All right, well, thanks very much. Good discussion.
Thanks for your time. Appreciate it.
Cheers.